According to a recent book by the National Research Council, a school laboratory investigation, also referred to as a lab, is defined as an experience in the laboratory, classroom, or the field that provides students with opportunities to interact directly with natural phenomenon or with data collected by others using tools, materials, and models. While reading about science, using computer simulations, and observing teacher demonstrations may be valuable, they are not a substitute for laboratory investigations by students. The National Science Teachers Association, or NSTA, recommends that all teachers of science provide instruction with a priority on making observations and gathering evidence to help students develop a deep understanding of the science content. This is a story of a group of students in my high school chemistry class that studied electron configurations and atomic spectra. By placing atoms of a metal into a flame, electrons can be stimulated to take in energy and jump to an excited energy state. They then return to their ground state by emitting a photon of light. The quantity of energy in the photon determines its color. For example, red has the lowest energy of visible light, while violet has the highest energy of visible light. Most every student sees this as a direct correlation to the colors of the rainbow. So we start with a simple class discussion about rainbows. During the discussion, we try to draw upon some of the students' memories so that they can re-experience rainbows as they have physically experienced them before. This leads us to a concise lecture about the electromagnetic spectrum because it is important to understand that photons outside of the visible spectrum, including infrared and ultraviolet, may also be emitted, but we cannot see them. The arrangement of electrons in an atom determines the sizes of the electron jumps, and thus the energy and colors of the collection of photons emitted. This is known as an emission spectrum. In this way, the emission spectrum serves as a specific barcode of the element to which the atoms belong. With the naked eye, we can view the emission spectrum of colors all at once as one specific color. In the lab, we carefully described and recorded the flame test colors of 7 different metals. We used 2 different compounds of each metal. This variety gave the students the opportunity to compare the flames of many different compounds. The students captured droplets of the ionic compounds of the metals with a wire loop and then placed the loop into a Bunsen burner flame. With the lights dimmed and all eyes on the flame, each metal produced a tiny light show on the lab table. As mentioned previously, the flame excited the electrons within the metals, and when the electrons fell back down to the ground state, photons were emitted. Each metal produced its own specific color, or emission spectrum. As the lab was filled with oohs and ahs, it was apparent that the students were having an experience in the lab that would leave them a very distinct memory of electron emissions. The students were learning by embodied cognition. The act of burning the metals in the flame was helping them to store perceptual information that they would be able to call upon at a later date. They could mentally transport themselves back into the lab and remember things like the smell of the lab, their hand positions, and not only the color of the flame, but how the flame burned. This active learning experience was enjoyable for the class, and during the class discussion that followed, the students were curious about the topic and had a lot of questions. They wanted to watch me demo things like putting different metals together and doing the lab in complete darkness. The students began to compare the light from the metals to encounters that they have had in the past watching bright firework displays in the sky. As we returned to the classroom to discuss electron arrangements, I was able to draw upon these memories and make solid connections to the flame test lab. The following day, I did the electric pickle demonstration. As I turned off the lights and we watched the pickle glow orange-yellow, the students were able to mesh the pickle experience to the sodium flame that they had seen during the flame test lab. Since most students have tasted salty pickles, the association between the sodium ions and the orange-yellow flame became a little bit more solid. Unfortunately, in a typical science classroom, not all of the students are present every day. That is why one student had to miss the flame test lab. Although making up each lab would be the best for absent students, sometimes it is not practical. We can tell the absent student about the lab, but it will never fully replace actually being there. One way for students to sort of experience a lab is to see it in pictures and videos on the computer. I gave the student who was absent a list of websites to visit so that they could see the flame tests. She had to complete the same lab worksheet as the rest of the class. However, she never had the opportunity to see any of the flame tests being done in real life. The absent student was there on the day of the electric pickle demonstration. However, it was before she had a chance to view the computer files and had a different perceptual experience than the rest of the class. Finally, all the students had to take a quiz at the end of the week. They had to show me that they had a basic understanding of the electromagnetic spectrum and specifically the energy of visible light. The absent students seemed to do just as well as the rest of the class on that portion of the quiz. However, when the students were asked to call upon their knowledge of specific light emissions, the student who had missed the lab did not do as well. When I quickly and informally interviewed the students after the quiz, it became clear that doing the lab helped the students to remember details which they recalled to assist them on the test. The computer pictures and video led to different types of memories, which did not seem to stick as well with the student. Overall, I think that having the absent students use the computer to complete virtual labs is better than doing nothing at all. But the experiences that they have do not compare to the memories that students make while they are in a science lab.